Hello, welcome to Math with Mr. Dobrescu to the rescue. Today we are going to graph system of equations part 2. Let's take a look at our first example. We have 4x minus 2y equals negative 8 and y equals 2x plus 4. Usually when we have a system of equation, it can be written in this form. And sometimes we may have a symbol. Sometimes we may have this symbol when we have a system of linear equation to keep both systems of equations together. And because the equations are under each other, it is better to, like in previous video, to put the equations next to each other so we can solve for y in both equations. It's easier when we have both equations next to each other so we can solve for y. Let's rewrite the first equation. So we have 4x minus 2y equals negative 8. And the second equation we have y equals 2x plus 4. And let's try to solve for y in both equations. Let's take a look at the first equation. The first equation, we don't have the y by itself. So we would have to subtract 4x first on both sides. Let's subtract 4x on both sides. Whatever we do to one side, we do to the other side. So minus 4x on the other side. 4x minus 4x cancel each other out. So we have left over with negative 2y equals negative 4x minus 8. Negative 4x minus 8. Now we are going to divide both sides by negative 2. Let's divide negative 2 on both sides. Negative, right? Negative 2. So negative divided by negative becomes a positive. So we have y equals negative 4 divided by negative 2 becomes negative, actually positive 2 over 1. 2 over 1x. And negative 8 divided by negative 2 becomes positive 4. Plus 4. And that, now we can label the m and the b in the first equation. So the m is 2 over 1. That's our slope. And the y-intercept is 4. That's our b. Positive 4 is our b. Okay, so the first equation is now in the y form. Let's take a look at the second equation. Second equation is already y, it's already by itself. But remember, we have to put a 1 under the 2 because we need to get that slope. 2 over 1 is our slope, our m, and positive 4 is our b. And something interesting is happening. We see that both equations have the same m and the same b's. Let's graph them and see what we get. Okay? So the first equation, we have b is 4. So we go 4 units up. 1, 2, 3, 4. And then we go 2 units up and 1 to the right. So 1, 2, and 1 to the right. And then let's connect the dots. And this is our first line. Okay, first line is done. Our first equation is done. We connected the dots. And now let's connect the second equation. The second equation is the same thing. b is 4. So we go 1, 1, 2, 3, 4. And the slope is 2 over 1, the same thing. 1, 2 over 1. And let's connect the dots. And as you see, both lines overlap. The lines overlap in this case, right? Lines overlap, right? Just like that. It means that any point that we get on both of these lines is going to be a solution for both equations. So the answer is infinite many solutions. So if both lines overlap when we graph the equations, our answer is infinite many solutions. Let's write that down. Infinite infinite many solutions. Okay? Let's take a look at the second example now. Second example, we have 4x plus 6y equals negative 12. And the second equation, we have 2x plus 3y equals 6. And the same thing, we can put this symbol for the both equations. And now, let's rewrite both equations next to each other so we can solve for y. We see that y is not by itself, so we need to make sure y is by itself first in both equations. Let's rewrite the first equation. 4x plus 6y equals negative 12. And the second equation, we have 2x plus 3y. 2x plus 3y equals 6. And let's solve it. Okay, let's solve both of these equations. In the first equation, we have to subtract 4x on both sides. So let's subtract 4x first on both sides. And in the second equation, we have to subtract 2x on both sides. So let's subtract 2x on both sides. Let's see what's going to happen now. 4x minus 4x cancel each other out. So we have left over with 6y equals negative 4x minus 12. Remember, we cannot combine those two terms together. So we have negative 4x minus 12. And in the second equation, 2x and negative 2x cancel each other out. So we are left over with 3y equals negative 2x plus 6. Okay? And the final step, we are going to divide both sides by 6 in the first equation. Let's divide 6 on both sides. 6 divided by 6 becomes a 1y, or y equals negative 4 divided by positive 6 becomes negative 2 over 3, right? We see that 4 divides 2 and 6 divides 2. So that becomes negative 2 over 3x. And negative 12 divided by 6 becomes negative 2. Negative divided by a positive becomes a negative. And 12 divided by 6 becomes 2. And now we have the y, we have the m, which is negative 2 over 3. And we have the y-intercept, which is negative 2. That's our b. For the second equation, we need to divide both sides by 3. So let's divide 3 on all sides. 3 divided by 3 becomes 1y equals negative 2 over 3 x. And 6 divided by 3 becomes 2, plus 2. Plus 2. And let's label the m and the b. The m is negative 2 over 3. That's our m. And the b is positive 2. And what do we see in these equations? We see that both equations have the same slopes, right? Same slopes. So when two equations have the same slopes, we will see what is going to happen. Let's grab the first one. We have negative 2 for b. So b is negative 2. So we go 2 units down. 1, 2. And then m is negative 2 over 3. So 2 units down, 1, 2, and 3 units to the right. And that's our first line. Let's connect those dots. The first equation is done. We graphed it. And now let's graph the second equation. B is 2 in this case, so we go up 2. and the slope is the same, negative 2 over 3. So we go 2 units down, 1, 2, and 3 units to the right, 1, 2, 3. And let's connect those dots. So in this case, we see that the lines are parallel, right? It means that there's no solution. Because the lines are never intersecting, they cannot intersect because they are parallel. So the answer is no solution. I want you to remember that again, if we have the same slopes, if both equations have the same slopes but different y-intercepts, the lines are going to be parallel. No solution. No solution. No solution. Okay, let's recap a little bit. Let's take a look at the first example here. In the previous video, after we graphed the equations, the lines were intersecting at one point. So again, we have one solution when the lines of the system of equations intersect. So if the lines intersect at one point, we can say we have one solution. One solution, the lines intersect at that point. Equations have different slopes. The slopes are not the same. Let's take a look at another case here. In this case, like just the example we had, if the lines don't intersect, if the lines are parallel, we can say the lines of the system of equations are parallel, never intersect. There's no solution. If the lines don't intersect, we don't have a solution. Equations have the same slopes, but different y-intercepts. Remember, just like in the second example we had today. And then our final option is infinite many solutions, just like our first example today. The lines overlap, right? The lines of the system of equations overlap. Equations have the same slopes and the same y-intercepts. Infinite many solutions. I hope this example gave you more practice of this intricate system of linear equations. And again, perfect practice makes perfect. Thank you all so much for your time. And I hope you had some fun in this mathematical adventure. And thank you for your time. Have a great day. Don't forget to like and subscribe and share this video with your friends and family members, because again, we want to make sure that everyone has the chance to learn graphing systems of linear equations. Thank you. All the best.